AudioJungle.
Welcome to SCI Storm. Newton's 3 laws of motion will be discussed in this video. Prior to any force acting on an item, it remains still or continues to move. Second, force influences acceleration depending on mass. Third, each action has a corresponding and opposing response. Come along with us as we investigate the wonderful realm of motion. Newton's laws of motion, formulated by Sir Isaac Newton in the 17th century, are fundamental principles that describe the behavior of objects in motion. The first law, also known as the law of inertia, states: Newton's first law of motion, law of inertia. An object at rest will remain at rest, and an object in motion will remain in motion at a constant velocity along a straight line unless acted upon by an external force. This law essentially means that objects tend to maintain their state of motion, either at rest or moving with a constant speed in a straight line, unless an external force is applied. In other words, if no net force acts on an object, it will not accelerate, and its velocity will not change. This property is called inertia. For example, if you slide a book across a table, it eventually comes to a stop due to friction, an external force, acting against its motion. If you toss a ball into the air, it will eventually fall back to the ground because of the force of gravity acting on it. Newton's second law of motion. The acceleration of an object is directly proportional to the net force acting on it, and inversely proportional to its mass. Mathematically, this law is expressed as F equals ma, where F is the net force applied to the object, m is its mass, and a is the resulting acceleration. This law tells us that the greater the force applied to an object, the greater its acceleration will be. Similarly, an object with a larger mass will require more force to achieve the same acceleration as an object with a smaller mass. For example, if you apply a stronger force to a shopping cart and a small toy car, the shopping cart will experience less acceleration compared to the toy car because the shopping cart generally has a larger mass. Pushing a heavy box requires more force to achieve the same acceleration as pushing a lighter box. Newton's third law of motion. For every action, there is an equal and opposite reaction. This means that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force back on the first object. In mathematical terms, if object A exerts a force on object B, action, then object B simultaneously exerts a force of the same magnitude but in the opposite direction on object A, reaction. For example, when you jump off a boat, the force of your feet pushing down on the boat, action, propels you upward, reaction. When you push a wall, your hands exert a force on the wall, action, and the wall exerts an equal and opposite force on your hands, reaction. These 3 laws laid the foundation for classical mechanics and are essential for understanding the behavior of objects in motion. They have been extensively validated through observations and experiments and remain cornerstones of physics and engineering to this day. We appreciate you watching our video about Newton's laws of motion. Don't forget to subscribe to SCI Storm for more engrossing material on diverse, scientific wonders and discoveries. If you enjoyed learning about science with us, click the subscribe button to keep up with the weekly release of thrilling new videos. Keep in mind that knowledge is a never-ending storm.